So to help you recall what operating systems can do. Okay, operating system is the system programming, system programs which handles everything about your application programs, all the management of your system itself. Management, therefore, network management. Without operating systems, network cannot be properly running. And your application systems, application programs, for example, if you are working on Microsoft Word or PowerPoint, the application program should be loaded on the memory first and should be handled by CPU. And also, if you change anything, then periodically the updates needs to be persistently stored on your hard disk drive. And at some points, if your application system needs to talk remotely somewhere through the internet, then it should be taken care of also. So basically, we have system programs and application programs. One of the system programs is operating systems. Okay, operating system, particularly for Windows operating systems, we call that Windows for your PC. It's a big size. Okay, there's another type of operating systems running on usually host on server programs, server systems, which is called the Linux. The size of a Linux is usually very, very small. The size of a Windows is very, very big. And all the times, if we have any problems, then it's caused by operating systems. The problem that I have here this morning, running my application programs, is purely from the Windows operating systems problems. So what operating systems can do, and what PCs operating systems can contain. Operating systems basically has two parts. Pure core part, we call that kernel level of operating systems. Okay, and then all other utilities. For example, file management. Operating system. One of the operating system's responsibilities is the management of files. You want to work on using some application to save your data as a file, and files needs to be properly managed. All file management is one of the major functions of operating systems. Okay. I think we looked at last time how operating systems can be then initially loaded, right? There may be some other programs so that they can be handling loading operating systems on your memory. Bottom line of your computer operation is that anything, if not on memory, cannot be handled. Should be first on the memory, and therefore CPU can handle whatever pieces available on the memory, right? So memory management is another important the functions can be handled by operating systems also. A lot of algorithms developed, still developed. Not all of them are implemented in Windows operating systems, but all of them are available in Linux. full size of Linux, not, for example, micro Linux operating systems, which is running on your smartphone, right? iPhone or Android. They're all having micro systems of Linux. Operating system that we are looking at here is not particularly Windows, but in general. Python provides also some accessibility to operating system level management. By default, Python therefore provides two modules, sys and OS. Okay, two different modules. Those modules are not imported by default. So every time if you want to use one of those modules, then you have to import it explicitly. Difference between sys and OS is sys is the modules containing the functions that should be available in most general operating systems. If you import OS, then all the functions that you could get by importing OS is your operating system dependent functions. If you are importing OS from your Windows systems, then all OS functions is relevant to your Windows operating systems. If you run this Python Linux and import OS, then that is a Linux OS. Okay. Basically, that is it. Let's see. Let me see if there is any other. Okay. Before we get into the operating system hands-on practice using Python, I want you to know this. I think some of you already know, but the following slides, we can tell you the concept of multi-threading. Now everybody is talking about threading, right? But I want you to understand that when we talk about multi-threading, what it means. And when you say multitasking, what you say multi-processing, they are all different levels of processing on your operating systems. Okay. Multi-processing is this. You have one CPU. If you have multiple CPUs, then we don't have to say multi-process, because each individual CPU can handle a process at a time, right? At particular time frame, one CPU can handle one process. That's a single process system. If you have multiple CPUs, even old technologies, one CPU for one process, overall, then there's a multi-processing. That is not what we are saying, right? Anyway, there is a multi-processing. Can you have similar processing and similar benefit from that processing, even though we have one single process, one single CPU? Therefore, we developed multi-processing about 40 years ago, right? So time sharing is very, very important. You start up one process. And if you look at one process means one program, one of your program. For example, if you run Excel program, if you run Microsoft Word program, and some network programs. Whenever you run a program, CPU may not needed to run maximally from the beginning of that program to the end of that. CPU runs so fast, but your application program runs a lot slower than CPU time. Then some of the works during working on some, the CPU may be involved. The CPU needs to take care of that. But your program needs, while your program needs to access your hard disk drive, then hard disk access even there is time is very, very slow. So CPU still needs to idling, right? CPU is so slow. I'm so bored, right? Something like that. Is there anything that I can do while this guy is accessing something else, right? So what the idea is that we can start multiple programs at a time. Only CPU handles if some time frame that program requires. And at another time, CPU also involved to handle that much, while therefore during that time, the audio program could do some time-consuming process which doesn't require a lot of CPU times. For example, if it waits some other remote response, something like that, right? So a lot of programs can running during some time period. All of them rely on one CPU, but that is still possible if small piece of each programs can be intervened each other. Okay, that's the time sharing. So this is a process. Process is a program. If you look at the process, then program. Some program is very active. Some program is inactive. Although they are all available on the memory and ready to run, but they are not all active throughout all time periods. Okay, so we can chop the time into smaller pieces, and therefore we can schedule. Okay, during this time, CPU comes here, and then for the rest of the time, okay, that is CPU. Well, we don't need to use CPU. You handle for something else. Actually, if you run a program, then that program is called the process. In the context of the operating systems, then your program should be loaded in memory. The way it is loaded that way. Your memory has a memory address. Of course, in this case, we do not say yet if this is a full size of a memory, then definitely there is some other spaces allocated and blocked for operating systems. Hey, this blocks your application data cannot touch. This is a preserved. This is a pre-reserved and should be kept safely. Therefore, my operating systems should run in full capacity. Otherwise, your operating systems itself runs so slowly, something like that. So there is another part operating systems. Depending upon the operating systems, some OS portions stores here, some OS portions stores in another, right? Anyway, this is the portion that we can use for our application programs. When application is loaded in the memory, they are not occupying memory consecutively, but pieces of those are, for example, program itself loaded here, and while you are working, for example, programming, then you create variables, then variables and functions, then it stores here in the stack. Stack grows from top to bottom, and there is another space, heap. It grows bottom to top, and some of the data stored here, for example, constant global data, right? That stores all here. So only your program can use during being processed this range. So some of the data increases from bottom, some others from top to bottom, right? So there's a limited size of space available, always limited size, right? If a program creates a lot of intermediate data, then it grows so fast, and some of the variables also grows fast, and there be some places, at some time, a collision. When it comes to these two regions are collide, then your system gives you an error. Many times it says stack overflow. What does that mean? It means this stack space grows and then overflows. There's no other way that we can securely save and handle your data and programs. That's what it means. If we have one program, one function calls another function, then another function comes here. When it through all the functions, it should go back to the caller program. Okay. So there is a place that cyber attack starts. What cyber attack starts is this. You load your program, and some malicious programs stay somewhere here. We know that address, okay? And some others trusted program is running very nicely. One program calls another, and this function calls another within the same program. For example, this generates another variable where while this is running, I want to put some data here. Address of this somewhere here. So I use this space where there is. This is not anymore the. When this function ends, then it reaches the last memory space here. Therefore, this guy knows where it should return by looking at this. So this guy knows, oh, I can return to my caller program. Meanwhile, I want to put this address there. So when this program runs and reaches the end of that program, therefore I assume that I know where I need to go back. When I reach there, so that I read the memory address, so I go back to that memory address, but that is not the caller. This is something else. So while you are running this program, it's not really properly running. Meanwhile, it runs something else. where there is a malicious code. Okay. Well, I need something else. But in general, when you run your operating system, application programs, then application program should be loaded on your memory, and therefore it is treated as a process in this way. If you look at one process, then there's a multiple states available. If it comes in newly, there's a new state. If you finish it, your application program, then that is terminated state. In between, we have a running state. So your program is running and waiting. For example, at some points, it needs wait for user input, for example, if that is a user interactive program, or if it needs to talk to some other programs, then it still needs to wait. So another mode is definitely reasonably available. And after the waiting, then before it get back to the active states, there's a ready mode. Okay, so during all process always starts from the new, it ending with the terminates. In between, it runs, waits, ready, and runs, waits, ready. This keep going, right? And when it is done, then terminates and go out, right? Continually. During the time of this waits, then CPU could do something else. Okay, that's what we were talking about. This is a very nice the slides that explain what operating systems can do for two different application programs, P0 and P1. Okay, they are handled by one CPU during the same time period. Some sharing. Multi-threading. See here, if we have one single CPU, then it runs like this, right? If we have a multi-threading, that's a very, very nice idea. This is a multi-thread. This is a good comparison. If there is a single thread process, as we looked at, there's one thread. If you have one code, memory zone, data memory zone, file memory zone, you have a stack, and then it grows. You have one management like this. If you have multi-threading, then this looks like one single memory management. It runs by itself within their management frame, but at the same time it provides the similar things for another program, another task. Similarly, this also. What it means is that your CPU can handle not only in this way, only by so that you manage multi-application programs by time sharing only, but in this case, multi-threading, then it allocates different memory management for each program. Not only time sharing, but much more than that. Therefore, each system can run as if it is handled by one CPU fully. Okay? It's much, much more powerful. This is multi-threading. So multi-threading and multitasking, multi-program processing, all are available in Python also. All the programs can handle this. Java program handle this, and Python program handle this also. Okay. This is one of the important concept of operating systems. That's what I want you to know. And now we'll go back to the Python. So, for example, Python, if you have OS imported, then OS can, as I said, OS modules is very similar to sys module. Sys functions available in sys modules is very, very common to all the operating systems. OS functions available and provided by OS module is more specific to the OS that you are currently working. Okay. So if you import OS, then we can also change directories from one place to another place. We can also look at the list of the data there, list of the files. On Windows graphical user interface mode, you may not know much of the command level operating systems, right? But let me remind you of some. If you run on command line of Windows, I'm going to okay, this is command line for Windows. Let me okay. Change directory. How can you do change directory in Windows systems? CD is the change directory, right? Get CWD. CWD means current working directory. So it tells us where I am right now. So all the file systems in operating systems, doesn't matter Windows or Linux, this is slightly different, but all the same. In the Windows systems, there are two types of files in one directory, right? If you do dir, then I can see it's no good. Turn over. So I can see dir. So I can see some directories. Okay, 505. What I'm trying to show to you, I'm going to show to you all in multiple column, but because of some files are so long, I cannot show them all. Let's see. Still, because of this. Oh, this is better. So I have two columns, right? If you see this, a particular directory, where I am right now, I am here, right? Windows systems does not develop a command that tells you where you are. But by default, it describes all the time. There's no other way that you can change this prompt. So always it gives you full path expression. Of course, you can change this. You cannot change this by your command, operating system's command. But you need to do program, system programs. By default to that. Linux operating systems is not, right? You can change it at any time. You can hide it so that anyone comes here, if you hide it, do not know where you are. Therefore, usually it needs to check get CWD. So it tells you where you are. Without having any this kind of command, your Windows systems by default always shows in this way. Okay, difference between the Linux and Windows systems. Let's see. Do I have any subdirectories here? By the way, there is no subdirectories, so that I can make some subdirectories. mkdir abc. Then I can see here abc is the directory, right? The Windows systems treats differently, treats files different from the directory, vice versa. There's a Windows systems. Okay. Linux operating systems treats the same. Anything file itself is a file. Directory, why not? That is a file also. So everything file. So uniformly managed, which is very clean and very easy, right? But in this case, in Windows systems, if you do have this, if you want to see the directories only, then you need to do, this is some trick, dir and star dot, then it gives me the directories only. If you have a dir, simply dir, then it lists all. If you have a dir, and then there is an option /w, then it gives you with W means I want to list them in width and wide level, so that it gives you multiple lines. Okay. So chdil, that is available as we do have in Windows systems at Python. So we can call the function chdil after import OS module. CWD. List dir is nothing but dir in Windows systems like this. If you do list dir, then it lists everything contained in that container. What is a container? Container is the directory where I am right now. So it lists all. So if you have list dir, then there is nothing but dir in Windows. What is the command in Linux for dir? ls. ls for list. Yeah. mkdir, as we did mkdir in previous command, same command, right? I made mkdir, and same thing here, mkdir. And remove, I can remove some files, right? Or directories. If I want to remove dir, this directory in Windows systems, then I need to do the command. What is the command? rmdir. Remove dir, then I can remove abc. But Linux, the command for that is rm. In Linux, since it treats files and directories equally, doesn't matter. Remove directory or files, both are using RM. So remove files, remove directories. So remove dir ABC, then it is gone. So there is no ABC. And rename, possible. In graphical user interface, the Windows systems, when you need to rename, you simply click slightly and then you can rename it, right? Here, if you want to rename, then say, well, I want to rename one of, okay, Mercy Python. Then if I want to rename it, then there are many ways that you could do, right? You can make a right click, or if you click slightly, then it's highlighted and that is editable. There you can change it, right? Whatever you want. That's whatever you want to file, right? That can be done here. If you do here, then there is whatever you want. Files, right? You can rename it in Linux command. Rename and whatever you want. .doc to, I think previously Mercy Python .doc, something like that. It's changed, right? The dir, then there's no whatever, but we have a Mercy, yeah, Mercy Python. In Linux, rename is command for rename is move mv. RM, there's a remove. mv, simply move. So mv in Linux is very similar to copy. CP, copy for CP for copy. Copy is only for copy. Move, copy, but original is disappeared. Cut, yeah. And remove dir, that's what we did. So these things, what you could do in Windows command line program can be done on your Python by calling functions. What is the beauty of this? Your program itself can handle operating systems. Series of Windows commands can be handled by your Python script. There's a first step that you can make your manual operations automatically by scripting in Python, right? Another okay. There's another functions available. For example, if you want to execute program in your Python, that is also possible by calling execl. This is a function. This function takes command and data. Command is a Java-C, and data is abc.java, your Java program. Therefore, your Java program can be compiled in this way. CPU count tells you how many CPUs are running. Get terminal size tells you the size. and get login, it tells you who are logged in your system. Get a PID, it's a process ID. It tells you how many all the IDs, all the list of all the programs are running in ID. Dr. Rao is calling. Hello. Yeah, I'm now teaching. Yeah, yeah. Do you have any urgent? Okay. Okay. All right. Thank you. Thank you. Yeah. This is a rename that we looked at. So we want to practice this also. Okay. With that simple possible, the understanding of the possibilities of accessing operating systems from Python point of view, we'll take 15-minute break, and when you come back, we will do practice in Python. Python is very, very powerful in that way. If you see the text, I describe, for example, at the end, that is on the exercise, the last exercise of this this section, is that you want to search some of the keyword by looking at all the files in your PC. Can you do it? Windows systems has built-in features so that you can search file name, right? File names can be searched in the Windows systems. But Windows systems doesn't provide you to search inside the files. You have to do it manually. Although it is a text file, you have to open up. Once you open up the file, then you can search. There's a search command. So you can search. Close it and open up another and search, and another and search. The way that you could do manually can be done automatically in Python. That is this program. Okay. So up to this point, there are a lot of steps that you have to learn and understand. And we're not going to do all throughout that points, but those who are interested in, try. But we'll practice a little bit of the exercises and examples here. Okay, after the break. Okay. Okay, when you open up, let's do first user interactive mode. Okay. So you simply run Python, or if you do not have a path environment settings, then you can do simply C:\Python 34, which is the directory that I put my Python program. So Python, call another Python, and enter. Then that is user interactive mode. If you do os.chdil os.get cwd, then there is an error because OS is not imported. So what you need to do is to import OS first. And os.get cwd, then it tells you where you are right now. the way that you can see, the prompt only this, right? Only triple greater than signs in your Python user interactive mode, right? Then without knowing this, if you are only here, then you do not know where you are. To know that, you need to run os.getCwd, then you will have this. This is exactly same as this. If you want to see what functions available in OS modules, then help and type OS. It tells you some of the functions that you can see. Stat result, and stat VFS result, and terminal size, times result, unnamed result. So many functions that can handle or utilize operating system features. In this case, the Windows. Access, chdil, change directory. If you look at this, chdil takes parameter. Parameter is a path. Change the current working directory to the specified path. So you have to do this very carefully. The path expression is very, very important to run this function properly. chmod is the access permission in a file. This chmod is not meaningful for Windows operating systems. Chmod is really for the Linux operating systems. Okay, access can be controlled in Linux operating systems. Then we need to use the chmod and CPU counts, dupe if you want to duplicate. This is the command that we looked at. If you want to run the host language or the programs running on host, not within your Python, but running on host, then you can execute this. Execute file name. If that file name needs any arguments, then list that arguments. See here, star argues means you can give arguments, 0 arguments or more. Some programs do not need any. Some programs need more, right? So we'll practice some of those here. For example, os. What is it? CPU counts, somehow like that, right? CPU count. Let's see. CPU count. 8 CPUs. Strange. CPU counts. Oh yeah. Core, yeah, core, yeah, right. Yeah, each one's different CPUs, right? Yeah. It, 8 CPUs in my case. It's all printed in one uh, board, one chip. It's not 8 different chips, but one chip having all 8 CPUs in my case. What about yours? Four, great. Tony, what is yours? Tony, you have a Mac, right? So you can run some of the programs, some of the functions here um, too. But I think even if your MacBook has 2 CPUs, it may run as powerful as 8 CPUs, which I have. Yeah. OS dot get PID. Oops, what is that? Get PID. Oh, there's a PID, then it needs some arguments. There's no attribute to get PID. Oh, okay. There's no underscore. Oh, 80, 89, 49, 8, 49, 48 PIDs. Get PIDs. I think that is a PID of this program. Okay. And if you want to run external program, then execl, the first argument is the file name. File name, which is nothing but the program, and which is nothing but the process. Same thing can be named differently. If it is stored, then we can call it file. In programming level, we can call it program. In operating systems level, and if it is actually loaded in memory, we call it process. But anyway, if you want to do, for example, Wireshark, if you want to run Wireshark, Wireshark is not needed too, right? Let me see. Quit. Oh, it's not recognized. So we have to. Where is Wireshark, by the way? Program files. Is there Wireshark? Oh yeah, here. So Wireshark. There's a Wireshark exe. Okay. So how can we run it? There. Import OS. Import OS. And os.execl. We need to change directory. chdil on top. OS chdil. I think. I put // see if it works. So os dot get cwd. Then I am on top right now. I want you to note here. I gave // but this guy understood it and converted to this particular operating system's paradigm, which is double backward /. Okay. And then we can do os.chdil. and program files. They all are program files. Okay, and then I can do os chdil Wireshark. Okay, and then os.get cwd. Then I know where I am, and then I can do chlist dir. Then I can see all the programs within that directory. So we need to see if there is a wireshark.exe. Yeah, there is a wireshark.exe. Now we are ready to execute os.execl, and then I can call that program wire. Well, anyway, in this way you can practice. Okay, all this, the way that we manually programmed can be also saved in a file like this, dir scan0.py. What it does is that it displays the files and subdirectories for a given directory. All right. Let me explain this program. It imported two modules, SYS and OS. So it first lists the OS name. All right. So print OS name. In my case, it returns NT. So Windows NT. The operating system itself is NT. There's Windows, new technology at that time, right? About 10 or 15 years ago, maybe 20 years ago. There's Windows operating systems newly developed. It is called the NT. And all the Windows model that you have, Windows 7, XP, 10, they're all graphical user interface. The different versions of a graphical user interface. Internal operating systems remains the same. It's called NT. That's what you can see. And after that, I have a for loop. In this for loop, it needs sys.argv. What this sys module is, if it has this variable argvs returns you the list of the arguments. As an example, we can practice it. For example, if you go to interactive mode and then import sys, and then you can say oh, it's not a good idea. We need to do practice in another way. Okay, so I can do notepad sample sys.py. In this sample, I can do simply import sys, and then I can do print sys argv. That's it. And then I can save this as a file .ps .py. Okay, and then I need to see if there is a py. Yes, sample py. Sample py is this, and I want to run it. The way that I run is this, and then sample sys.py. Not just enter. I want to add more arguments, system level arguments. I want to put here A, B, C, D, E. See what happens. When I type that, then according to this program, wants to read all the arguments given with the command line. That is a sys.argues. This is a variable. It returns a list of all the arguments, including that command itself. So it returns, it includes the command itself, which is you can see here, and all the arguments A, B, C, D, and E in the format of a list. Okay. Therefore, you can expand more. Print, you could say the program is sys.arg. What is the program name? How can you access this first program, the first element of that list? That was in the midterm exam also. 0. You can say 0. And then print all the arguments associated to are. How can you list all arguments except the program itself from the args list? 1 and colon, right? And then we can save it. Save as that Python file. Therefore, you can hear the beep, and you can call it again. It's like this. Very nice, right? Compare this program and your application here. It says the program is this, sample sys.py. All the arguments associated to that program are, that is, can you say also not the list level, but can you display it? Or for print ELE. That's it. And save it. Save as that, save it, and run. All the arguments associated to sample sys.py are and list. The previously it gives me the list format. Now just text. The way that I ask you for your midterm, Shivani, you did a good job here, if I remember. Can you add them all in one line? Tell me. Forgot? Yeah, I mean, for loop, while loop, they are the same. Right now here, A, B, C, D, E, each line, but I want to have A, space B, space C, space D in one line. And if you want to make a space in between, then you can do like this. Right? So exactly, I asked me. This is the program. I want you to practice this. This will give you the list of all the content in that directory. Finally, CWD, not using pretty print, but by programming something like this. The host OS is NT and then a list of file names. You can compare. This is.
Oh, so you take it out of the actual list brackets.
Yeah, this is list format. See here, the close. But in this case, only the name of files, list of name of files. It's very simple to add this instead of print files. You can do another for loop. Another way that you could do very nicely in this, like this way. The host OS is NT, and then there is some indentation. List all the content. At the end, you can say they are contained in this container. If you have multiple directories like that, then you can do research. Then, for example, the OS NT, this is a contents contained in this, and another contents, they are contained in this research directories. Make it better than what? May try this. We have some slash, and then the directory names, and then we can say this directory contains, and it contains a list of that, and then another directory that contains another. And then finally you can say 18 times. And the next line, I want to make 18 spaces. So quote space quote times 18, then I want to make 18 spaces. And then I explicitly states contains and change the line, next line. And then in the for loop, I make all list of the files, but I commented out here, so this doesn't affect. I simply tab and file name, and at the very end, when it is done, then I can do. I'm going to give you another text that I prepared. I think now it is it's quick to run. Those who are interested in can read this, but I can explain this to you quick so that some of you may like. Recursion.
As we expand this program, given directory may contain another subdirectory. The same idea that you implement here that you want to apply to the subdirectory also. As far as there is some subdirectories, so it can be further expandable that you want to omit and list all the contents. If you do it in the sequence programs, then you cannot do it because you do not know how many people, how many levels you can go before. Sometimes there is there is a last directory. There is no further directories. Sometimes there's a 10 different levels, different depth of the subdirectories possible, right? So you cannot, because you do not know, your programming is not simple, right? In such case, you have to do the recursive program. Recursive program is very, very important in many cases. A recursive program is not taught fundamentally, but it needs in many cases. Recursion is not efficient in a way that it holds some, at some points it holds it for the expense, it holds for the expense. If you remember that memory management, then program goes up and stack that is registered before the stack before it is ending. It pulls another program, but that pulled program is nothing but itself. So before it ends, it calls itself again and again and again and again. So sometimes I may appear in the memory 10 times or 20 times. All are.
I think this. So, okay, there is a recursion. This is a list of the input arguments, and this guy is sent to this function. So in this function, LST is nothing but arguments. So in the arguments, for each element, I want to do list dir, and print that dir, and then that LST is defined again. This is the key points of recursive programming. LST is redefined and then call itself. Do you see this? Not many people. This is the function name get file. This is the function. In this function definition, there is a statement that can call itself. There's a recursion. Call itself But if LST is not changed, then it calls continually. There's a never ending, right? But that is not the case here. LST is redefined before it is called. What is the LST? LST is nothing but the list. See here, there's a list format. If you look at this inside, let me explain only, rather than ask you to understand that code. What it does is that it picks up directory only. Pick up the directory from the list of content and make it in the form of a list and call itself. So conceptually what it does is that it lists all the contents and pick only the subdirectories and form them in another list and send it itself. Then it keeps doing that continually. If there is no list, then that is the point it stops. All right? We're not going to do that here today. This is too much to you. And then the first section of that chapter 5, that is also someone may be very, very interested in, which is here, command line. In this example today, you might have multiple arguments, right? There's no limits, no strictly defined fashion. So dynamically, your program can understand the input arguments in the command line, which is good so far. But we can expand that idea further by giving some option. We can discriminate from the general arguments. The idea already implemented in many cases in Linux. Look at this. When you do C compiling, GCC, look at these statements. GCC, this is compiler, so it needs C programs. Usually we have only these two. But there's another options. For example, -o followed by the file name, then output will be stored in that file. That's what it means. If we have a -g, then we want to activate the debugger. So when we execute some file, some programs, we may state optionally some options in addition to the arguments itself. Options, therefore, you can state it or you may not. If it is stated, it should be understood that way. Can we make such programs in Python? Python is the only language very powerful, accommodating options and arguments. Okay, so those who are interested, take a look. Only thing that I can give you hints is in this way. You have to, if you look here, this is only from, this is exercise 5.1.2. This is a main program. Before you have a main program, this is the main program. All above this, there's extra. There's something that you define. Hey, there is this kind of option. If it is specified, you have to take care of that. If it is not, you don't need to. Okay, that type of things defined here. All right, this is the end of operating systems. The last topic that we have is database. Database. We have only 1 hour left. What time is it right now? We have 30 minutes. So I'm going to introduce to you something about database. And then next week, database. Okay. If you look at the text that I give to you, the audio, section 3.4. I wanted to open section 3.4. Last few pages. I think the last 3 pages. We can run this database in 3 ways. Oh, I didn't write it. Oh, I don't need to say that here, right? This is what I have. In 3 ways. Database can be handled in 3 ways. Number 1, you can make it, you can run it using graphical interface. Direct graphical interface. That's it. GUI. Number 2, you can use it to manage. This is a basic database concept. Quick review. Database is a collection of data, but all the data stored in a database are well organized. If any data not well organized, there's a lot of issues, right? Efficiency issues and effectivity issues and consistency issues. We do not know the data in that repository is really consistent. Is it valid? Is it efficiently accessed? So all issues are available. But those issues are not really main concern, then still you can use it. What is the domain? What is the application domain that not really needed, consistency is not really the issue, integrity is not really the issue, the efficiency is not really the issue. There's not many, but if we say then anything on the web, okay, no one trusts anyway, still okay. Efficiency, if it doesn't return very quick, still we can wait, right? Because there is no trust between server and clients. That's okay. But database is different. It's well organized, well protected, tightly. So all the money issues, money related data should be stored in a formal database. So well organized. How can we organize data in formal way? Then there should be a formal description about data. We call that schema. Schemata information. Okay. What is a schema? Schema is nothing but, well, we defined it. First, what is a database schema? Database, because database is nothing but a collection of a table. If we are talking about relational database, then table is nothing but relation. Collection of a table is called database. the structure of data in that database should follow some rules. Those rules are defined in schema. So each table has a schema also. What is a schema? In loosely defined definition is that schema is nothing but a list of we call that attributes. List of attribute is nothing but a table schema. Given table, what is the structure? Oh, it has 3 data tuples. First data is name, second data is telephone number, third data is address, for example. Then all the data in that table should follow that format. So our language, our database language assumes that if we extract the first column only, then we can say, oh, this is a list of student name. They're all student name. Second column, oh, this is a list of students' telephone numbers. This is a list of students' address. Okay? Structured, therefore, efficiently used. So before you use a database, you have to first define the database. In order to define database, you have to design the database in formal way. Design the database. What is the database design? What is the outcome of a database design? Outcome of database design is nothing but database schema, so that you have a list of table structure. Table structure. For example, my database contains 4 tables: student table, department table, faculty table, and class tables. Even further, student table has 3 attributes: student ID, age, and major. This is definition, right? And structural definition. Even further, we can define, oh, by the way, student ID should be in integer, int. Age should be in int. Should be formally defined. That is the formal database. You cannot say, how old are you? You can say, I'm so young. You may say that in informal, right? But in this database, you should give some number. I'm 7.5. No. Should be in integer in this definition, right? Major, this is text. But if you say, oh, what is your major? If you say, I'm undefined, unstructured computer science and data processing. Is there any name, any formal names of a major like that? I spelled the long name, right? There's no such. How can you define that? So look at this. Major for student, there's some line, right? Major some students should be first available in the department name. When you say major, then what is your major? My major is Python-oriented processing. Is there any department of Python-oriented processing? No, there is no department. So your major should be defined first in the department table. So your major is just picked from the department. That is the reality, right? So by looking at this, They are talking about same data. Major real value for major is the same as real value for department name. But there is some dependencies, master and slave levels of dependencies. Department name should first exist, therefore you can choose for your major. There's some dependencies, right? You cannot choose any major not existing. So a lot of issues. Those are all such dependency issues are automatically managed if you install databases. So rather than implement, you simply buy database engine and populate the data and use it. In that way, you do not have to worry about all such detailed programs. Database engine is nothing but a gigantic programs, packages. Okay, so there is some constraints and integrity management in database. There's a language. If you want to create table, the language is called create table. This is a standard. SQL is a standard. There are 3 standards in SQL. SQL 1, 2, and 3. SQL 3 was defined in, I think, 1992. There's a last and recent standardization. Earlier standard was 1970 or some. SQL was designed by IBM. IBM not here in Watson, but the West Coast. All the computer science researches in IBM handled in West Coast. We call that Almaden Research Center. So they developed all in 1970s. It's the first generation of SQL. As computer science technology evolves, there's a different standard came up in early 1980s. We call that SQL2. And then 1990s, we have SQL3. The point of SQL3, your language, your engines become more intelligent. It's not just a relational database. It's a lot more than that, right? Artificial intelligence features included in the database. After that, there is no standardization because it's very hard to standardize. Each company has its own specific features. They're all addendum. It's not really core database technologies. Oracle has its own technologies. IBM lost all the database technologies, but still has DB2. Instead, the Microsoft came up in early 1990s. So they recruited all major database researchers and put them in Washington State, and they developed a lot, but still some issues. Right? But Oracle is the leading companies. Meanwhile, Sun Microsystems developed MySQL, which is simple and still runs very well, and most likely it is free, right? It is acquired by Oracle, all hardware and software components. The Oracle still make it available for free. But Oracle is profit-oriented company, so they do not add more features to MySQL. But still okay. But Oracle has a lot of strong features, particularly for security, cyber security. Okay, anyway, this is a basic language. If you want to create table, then you need to start with the create table and the table name, open parenthesis, and attribute name and type of that attribute, name and attribute, name and attribute. If there is any constraint, then you need to specify that. For example, not null, that is a constraint. What it means is that when you create a table of instructors, any tuples in that table, any rows in that table, there shouldn't be no instructor's name. No data can be admitted if there is no instructor's name. Oh, we have instructors, but his name, he's 65 years old. He's very good at programming and whatever that is. And but by the way, his name is empty. Can you enroll him? No. That type of constraints, right? Without this restriction or constraints, if you are not using database, let's say simply Excel spreadsheets. Excel spreadsheet can contain any tuples with no name. Possible, right? You can enter whatever you want. But if it is a database table, then and it is defined in this way, then no way. If there is no name, then rejects. So all the data in your table and therefore entire database keeps integrity, keeps consistency. Therefore, when you retrieve data from there, it's also trusted. Once you have, so the process is this. You model this in schema. Once you have schema, then you can create table. This is a real implementation. If you have the table definition, then you can populate the data by this command, different command. These are all the languages available in the database. We call that database language. If you want to populate data, then you need to start with insert. Insert into where? One of the table. So instructor, then that is the instructor. That we defined above, right? Once I define the table, then I can enter the data there. So this is table name, followed by another keywords, values, and open parentheses. And then I can list the values in the same order of the schema. If you do not want to follow that order, then you need to specify in this language separately. This is another the language that as you create table instructor. If we want to say, for example, ID of instructor, that is the primary key. What's the key? Key means many in many different contexts, right? You have a key for your home, key for your car, you have a key to your encryption techniques so that you can decrypt it. And this is the key more in conceptual level. The key in this case is there's no duplication. There's a unique. Once you know key, then you know everything about that. There's a uniqueness. Because we need to keep uniqueness, automatically it should not be empty. right? It's unique. So if you want to identify each single element in a table, then you need to define, hey, this is the key, so that there's no duplicates. At Mercy, we have a CWID number, right? Students has a CWID, all the faculty and staff members also have CWID. It's primary key. If you provide your CWID, then someone can access, someone can identify who you are, right? That is the key. At the same time, we have a foreign key. What it means is that, go back, student major, for example. For student table, major is not a key. Somebody said, oh, why not? Oh, in the student table, you are the only one majoring that major? No, there's a multiple of your classmates. But what about department? If you think of the different table, which is a department, then department name should be unique. Is there another math and computer science department at the Mercy table? No, there's only one, right? No, name, department name in the department table. So list of departments. Will there be more than one department names? No, one, right? So name here, that is a primary key. Name, department name in the department table, that is a primary key. We can call PK. Same value may appear at another table, math and computer science. Although it appears at another table, same value, there's a meaningful. Without that value, there's no connection between students and department. Because there is common values appearing in two different tables. Therefore, through that common value, two tables can be combined, right? But existence of this value at the students should depend on the existence of department. The value here is not the primary key for students, but somehow it was the primary if it is in another department. We're talking about the same value. In such case, we call this foreign key, FK. FK, the value itself is not the key in my department, but it was the primary key at another department, and they are tightly related and dependent. My existence is not my alone. I exist here because I first existed at another department. Because department first created, therefore I can measure it. So department name at the department table is a primary key, but my major, although they are the same value, is a foreign key. Should we define it that way? Yes, in database. That is the mechanism here. I can say foreign key. What is a foreign key? Department name is a foreign key for instructor. But this department name, department name for the instructor, and where that instructor is associated, should first exist in the department table. Although we have the same value, for example, computer science, but that should reference to the department table. So my existence is not alone, but should rely on some other table. If that table removes that department, then my existence no longer available. So all dependencies. I can be created for my major if it is already available in the department table. If a department table removes that department, then my major automatically removed. That's the case, right? If Mercy closed math and computer science, then all the major either change or no longer. Database should reflect the reality. In that way, database can reflect exactly, seamlessly the reality, right? If we define that, then at least that context can be preserved in our database technologies. All right? Any questions? So with this small amounts of knowledge, next week we'll do practice. Practice in 3 ways. What are those 3 ways? Graphical user interface under database engine and using Python. We're all talking about SQL. Yeah. All right. Have a good weekend.